Okay, we're at a little over 2 minutes in, so let's go ahead and get started and get going here. So I'm going to start the presentation. And what I want to talk to you about today is iMachining's, SolidCAM's iMachining modules. Now, iMachining is an amazing product, and it's one that I truly believe that every machine shop can take advantage of. You know, there's so much more to iMachining than most people realize. And so I kind of want to take you guys through and cover a lot of this. We have a short time available today, but I think we can get into some pretty good stuff here. So, you know, SolidCAM is basically a full spectrum CAM system with modules to handle pretty much anything you need on your CNC. And one of the things about us is that we are fully integrated into 3 of some of the world's best CAD systems. That's SolidWorks, Autodesk Inventor, and Solid Edge now. And so that makes it a pretty powerful system as well. Now, today, we're going to be discussing the 2D iMachining and the 3D iMachining. And these are going to get us into a little bit of a technical discussion. Now, iMachining 2D includes the ability to recognize features in the model and to also look at those features, including their depths and things of that nature. We can do simple chaining, but we're not limited to the simple chaining, okay? And you can also use 3+2 index milling with iMachining 2D, which can be very powerful when you're working with multi-axis applications and you need to be able to rotate the part to one position, do a little bit of roughing, rotate to another part, do some roughing there, and kind of handle it that way. All right. And so one of the things that we want to talk about also is the spectrum of products that iMachining is good for. And really, iMachining can be used in many different applications, from anything from simple 2-axis machining all the way up through 5-axis impellers, mill turn, Swiss turn type parts. Any of those types of components that you would be machining on, iMachining has the capacity to rough those parts out much quicker and much more effectively than you would with other systems. Now let's talk about how iMachining works a little bit. There's really kind of 4 areas where we work and we capture data and we understand that data and we apply our algorithms to that information to make machining more intense, okay? On the material, we pick up the ultimate tensile strength. We use that as part of our calculation. We recognize the machinability factor of that material. An example is some of the 300 series stainless steels will be very similar in tensile strength, and yet they might be a little bit different in machinability, okay? And so we capture both the ultimate tensile strength and the machinability. With a material setup, we can set the maximum cutting angle, and of course we can set the minimum cutting angle. We'll get into that in just a few minutes and talk about why that's important. Now, with regard to the tool, the system recognizes the cut length of the tool, recognizes how many flutes the tool has. We also pick up the flute helix angle and understand how that impacts our axial contact points, something we'll talk about later in the presentation as well. We can establish a baseline chip thickness in the tool definition so that the system knows how to use that tool relative to a particular material. We can also set the grade of the material of the tool. So whether it's a micrograin carbide substructure or whether it's a macrograin or anything like that, that helps us identify what kind of performance that tool should be able to handle. Now, within the geometry of the part itself, we also capture the, we automatically pick up on the depth of the pockets, all right? We utilize the shape of the area that we're working with. Our algorithms do some pretty cool features with that. They actually calculate different ways of approaching the area based on the shape that is there. And we'll talk about that when we get more into the morphing spiral algorithm. Now, we also use updated stock. This is a really powerful feature in what we do with iMachining. We are constantly and continuously upgrading and updating the stock definition so that the tool knows exactly where to cut from. And that helps us to be much more efficient. We also need to know some information about the machine, the maximum spin of the spindle, the maximum feed that it can do a G1 at, what its maximum power is, the horsepower on the spindle, and of course the rigidity of the machine. We're able to put in a factor for that helps us to identify possible vibration issues that we might be running into. Okay, so that gives us a lot of detail that we can pay attention to. Now, as we start to talk about iMachining and how it works, especially as it relates to the cutting angle, if you will, this diagram helps us to understand how a tool is engaged in the material at different sections of the tool motion. And these are things that we really truly want to pay attention to. At cutting angles that are less than 90 degrees, you see over here on the left, the 55 degrees, the tool is experiencing force dynamics that are relative to chip thinning. Okay, and that's a different set of force dynamics than what we're seeing over on the right-hand side. On the right-hand side at 150 degrees, the initial engagement with the material, the flute is actually seeing a chip thickening condition. And of course, it's seeing the forces that are relative to the chip getting thicker and thicker as it moves through it. Okay. Now, these dynamics that apply to the tool in the area where we're greater than 90 degrees have a huge impact, and they can create multiple different types of vibration harmonics, as well as linear forces against the tool that can lead to excessive wear and in some cases actually breakage of the tool. And so we kind of want to keep ourselves away from that. Now, iMachining is an intelligent high-speed machining technology, and it maintains cutting angles between 10 degrees and 80 degrees maximum, and that helps us to eliminate these linear vibrational forces that can be seen when we're using traditional tool paths. All right. This allows SolidCAM to create significantly faster and yet safer CNC programs to machine mechanical components with first part success. I mean, really, you can set the values and go and know and trust that it's going to run right. All the while, this is helping to maximize our tool life and get us, better machining, more efficient machining, and a better part. Now, the morphing spiral, what we talk about, our morphing spiral algorithm, is responsible for really unbelievable cycle time savings. I know we talk about 70% all the time, but in actuality, quite often it's significantly more than that. And depending on the material, the condition, depths, and things like that, we can see some pretty significant improvements in cycle time. Okay. Now, the technology wizard is also, it's one of our patented technology applications. And this automatically calculates and optimizes the cutting feeds and speeds for each point along the tool path. And that's pretty incredible. This helps us to maintain a remarkably stable cutting force against the tool. We'll get into that a little bit as we go further into this as well. Now, when we talk about the wizard does many things. It solves all kinds of problems with trying to figure out what we want to do. Some of the other systems in the industry that claim that they do similar things to what iMachining does, you have to physically put in all the information yourself, where the wizard helps us. It looks at all of these different characteristics that we're seeing, that we're looking at, and it sets a series of interdependent parameters. Now that's kind of important because these parameters do depend on each other and they all work together. And so trying to figure out how to set each one of them relative to all the other ones could be quite complex. But the wizard actually takes care of that and handles that for you. And it's optimized based on the calculations that we are using with all of those parameters that we discussed earlier, from the material, tool, machine, and so forth. And so the wizard solves a lot of problems for us. Okay, now as we, sorry, bear with me just a second here, a little glitch on my computer. As we go forward and we start talking about that cutting angle, what exactly does controlled cutting angle really mean? Well, number one, it means that the tool is controlled in its step over, but it's not controlled by the radial engagement of the step over, it's controlled by the cutting angle, and that's important. And it gives us a lot more power. It means that the tool is never going to be over engaged or overstressed, okay? iMachining controls the step over by actually managing the cutting angle. So the step over is actually kind of a result of, it's not the driving factor. Now, iMachining also allows us to control the approach into and the departure from the cutting area. And it does this very, very specifically and gives us some factors to control that. All of this plays together to help ensure that the forces that are applied to the floor of the cut and to the thin walls, if that's the case, you know, in the geometry, are minimized to the best of the ability beyond any other machining software that I've ever used, okay? And again, based on the wizard, these parameters are automatically calculated to give us better control and easier programming as we're working with the system. Now, what is the morphing toolpath? What does that mean? Well, iMachining is always using our patented morphing spiral toolpath. And as you can see in this illustration, what's happening, the tool is always engagement controlled. There are no sharp corners. Every movement in here is always tangent, okay? The fast repositioning that you're seeing is what we call our D-slot trochoidal repositioning. It actually lifts off the floor a little bit and moves over to the next position quickly and effectively at high speeds. And again, the most important thing is that the tool is never, ever over engaged, okay? Now, as we come into this next slide and we start to look at this, this is an example of a closed pocket. Now let's take a look at how iMachining works here. Now first, you can pre-drill if you want to. In a lot of cases, we just helical approach down to the bottom of the full depth, and we then begin doing the spiral morphing algorithm, okay? And again, this is keeping the tool in constant contact, but it's also changing the shape as it goes along, all right? Now, one of the things that happens in a lot of cases, the morphing spiral is designed to stay within the minimum and maximum cutting angle range that the user specifies. When it cannot do that, then it transitions over into what we call the D-slot trochoidal repositioning move. And this allows us to blend the shape to an area where we can now go back into the morphing spiral. Now the tool can return to the morphing spiral where the material removal is far more efficient, okay? Now, as we arrive towards the end of what it's able to do, staying within, again, the specified user range of minimum to maximum cutting angle, then it's going to go ahead and it's going to finish out the pocket using, again, the spiral morphing algorithm, but using the D-slot repositioning to move the tool effectively and quickly, even within the region. Now, this also does some pretty special stuff in that it even avoids islands and such, because remember, with each movement of this tool, we are continuously updating the remaining stock, okay? Now, this is a great example of iMachining's expert shape management. And what I mean about that is we talked about the geometry earlier. Well, iMachining's algorithms actually analyze the topology of the area that's selected and makes decisions on how to handle that area. So as you can see here, there's a separation channel that goes along the back wall of this to separate this area from that back wall so that the tool can move around these other areas where it's going to do the spiral morphing efficiencies, okay? Now, the problem with a long, narrow area is that if you only have a single collapse point, that would not be a very efficient way of doing the machining, because all along the long edges, you're going to be cutting at a very minimum cutting angle, and across the short distances, you're going to be cutting at a very maximum cutting angle, all right? So what we do is, again, the algorithm actually analyzes the entire area, breaks it into more symmetric zones, uses these spiral efficiency separation channels to split it to create the final spiral areas that are far more efficient. And in fact, this one over on the left is virtually almost perfectly symmetrical in where it's at, width and length. And so it can stay very near or at the maximum cutting angle where we're gaining the greatest efficiency in the cut, okay? And so this is why we say that iMachining is the intelligent solution. Now, iMachining 3D takes us into a whole nother level. And this is one of those areas where really any customer can use this. Anybody that's doing anything beyond the most basic, simple prismatic parts could take advantage of iMachining 3D, because iMachining 3D has some great characteristics with it. It recognizes the entire model, okay? As it's doing that, remember, while we're moving, not just in a 2D format, but also in a 3D format, it's continuously updating the stock. So we always understand where material still needs to be removed and where it's safe to move the tool in a high-speed detour repositioning move, okay? It eliminates air cuts because we know where the stock is. We don't need to waste time approaching it cautiously. We can get right in where we need to be and start cutting stock, okay? iMachining 3D does automatic scallop calculations, okay? This is pretty important because this functionality actually helps us do semi-finishing while we are roughing. And we'll kind of talk a little bit about that as we go forward here. What this means is with iMachining 3D, it is very possible, in fact, almost always, you can eliminate semi-finishing moves with your ball tools, the semi-finishing tool paths that take so long to do, because the step up with the automatic scallop calculation and the automatic stock recognition means that we can go in and we can clear out areas very, very effectively, okay? Now, iMachining 3D uses all of iMachining 2D's advanced algorithms. And of course, it uses the wizard to achieve the best performance with the easiest amount of programming, right? Many times, not always, but in many cases with 3D, even mold cavity and core type parts, we can do the roughing in one operation. Now, we also have the ability to break up the area into constrained boundaries where we can have the tool work in specific areas only. But in a lot of cases, I've seen where it's very effective to just, one click and done. It also automatically does rest material recognition. And so in multi-tool operations, the iMachining 3D can do as much as it can do with a larger tool and then come back in and clear out little areas with the smaller tool. Makes it very, very, very easy to program. Easy on complex parts even. When you get into crazy parts, it can, can recognize multiple levels of rest machining. It's also 3D, just like in 2D. It's great for roughing with solid cutters. Now, a lot of people take that comment to mean that if you're using inserted cutters, you can't use iMachining, and that's just not true. And I'll show you something a little bit later about that, that it's very effective with those. Now, the step-up technology is, of course, driven by the shape of the model. And this is where the system uses the automatic scallop calculation to set the depths of cut for those staircases, not at constant Z-level depths, but at depths that result in constant staircase offset. Okay, so that's a pretty powerful function, because that gives us a predictability on the flex and unflex of our finishing tools as they're traveling across these surfaces. It also means that we're wasting a lot less time with the tool moving in the air. Okay. Now, as you can see in this representation, the tool does the staircase removal, right? It starts at the bottom, it works its way up to the top. And the reason that's important is because as it is doing the roughing and it goes to the next staircase, that roughing at that next staircase is automatically doing the semi-finishing. And that's what makes it so powerful. Okay. Now, in this next simulation, a smaller tool is coming back in and refining those staircases, as well as cleaning out the smaller corners. And so again, this gives us a great way of reducing the rough appearance of the machine, getting it down to a near net finish quicker than we would with a semi-finishing toolpath. We talked about a lot of things here. And so let's kind of go through and summarize the benefits of this, and kind of get into a little bit about the overall remembrance of what this does. Our trachoidal, spiral, and smooth tangent toolpaths are very, very powerful and very functional for us. We minimize retracts, we minimize air cutting. We're using the whole cutting length of the tool where possible. Okay, so we're not just wearing out the bottom of the tool and throwing away the rest of it in good condition. The other thing that's just really powerful at is that it is really protective of small diameter tools, and it also helps us machine better with thin walls, and that helps in many, many cases. Because of the way we're managing the tool path, and we're not crossing over that 90-degree quadrant into the greater than 90-degree angles, we limit it to 80. Okay, we're not producing the vibrations that create chatter, and that's a very powerful feature as well. Because of all this stuff, we can actually see improvements in tool life by pretty significant levels. Okay, remember, carbide is generally a tool that most people are using these days, but the carbide substrate is very hard. It is very abrasion resistant, but it's pretty brittle. It doesn't handle vibration stresses or shock stresses or even thermal stresses that can cause microchipping and diminish your tool life. With iMachining doing what it's doing, it is stabilizing all of those forces and actually giving us much better tool life. Now, kind of a side result of that, of course, is because all of that smoothness, we're also putting less stress on your spindle bearings. So we're increasing the life of your spindle in your machine. And again, we've always talked about 70% reduction in cycle time and the various different things that means. Okay, but we actually do a lot more than that, significantly more. Okay. The good chip ejection. Okay, this is something people don't think about a lot. If we're getting clean chip ejection, it means that the heat of work is coming off in the chip. It's not conducting to the tool. It's not conducting to the part. and therefore the stresses that are applied to the part, the stresses that are applied to the tool are minimized even through that, just the dynamic chip ejection. Okay. Now, we show this video a lot, but this is pretty cool. This is a tiny little desktop machine. This is a 3/16 inch 4-flute end mill that's running at 3/8 of an inch deep, and that was in cold roll steel. Okay. And if we can cut like this on a little machine, imagine what this can do on your full-size machines in your shop without stressing the spindle, without stressing the material, and resulting in much better, more efficient tool path. All right, so let's kind of take this conversation up to a different level. I want to go beyond the typical things that we talk about and go a little bit deeper into things that people don't typically think about. In this case, we're talking about exotic materials, all right? And iMachining can perform in exotic materials significantly better for roughing these than any other program I've ever seen in my career, okay? And I want to show you a little video here that is a very difficult to cut material. This is a Rene variant from GE. It's one of their proprietary materials for jet engine hot section materials. And what you're seeing is an NTK ceramic end mill helping us do this cutting. Now, there's some pretty interesting stuff about this that when we talk about, you know, jet engine hot section super alloys, the super alloy is it's not an overstatement at all. This stuff is some of the toughest material I've ever come across. It has what they consider a creep rupture strength, which is its ability to stand against stress at elevated temperature that is beyond most other materials. This is think of it as an Inconel on steroids, okay? A little bit about this, the typical customer cutting this material with a standard tool path and standard carbide end mills is cutting at about, maybe 15% of the performance, if even that you're seeing here, and at very shallow depths of cut, okay? And the tool life is very minimal. It's like 8 to 10 minutes, okay? NTK and some of the other tool manufacturers learned how to create these ceramic end mills, and with those ceramic end mills, they were able to increase the performance at the same depth of cut and increase the tool life by about 2 times. Okay, they were doing this with this NTK tool at their strategy. With the other softwares, they were getting about 24 minutes of cycle time. Now, what you just saw here, we're at 10 times the depth of cut that they were at about 1.5 times the performance, and we got 43 minutes on this tool, and it was still good. We just ran out of time to do more testing that day, and I didn't ever get a chance to get back to it. So pretty impressive what iMachining can do inside exotic materials. This is another example. This is with a Greenleaf ceramic end mill. This is in a tool steel that is basically 48 Rockwell C, okay, very hard material. But you can see with iMachining, one of the things that's really great about the way iMachining runs this is that iMachining is so smooth and the connections are so tangent and the entry is so controlled that we're never stressing the ceramic tool. The ceramic tool is a very interesting tool because it is extremely durable. Again, like carbide, but at an even higher level. It is very, very resistant to compressive force, but it does not handle tensile shock at all, okay? Now, another thing that people don't think about is noise. And this is a kind of an interesting story here. We were cutting in some Duracast with a 3-fluted 1.5 inch high feed mill, and using the manufacturer's recommended rates on this tool with their previous software, they were hitting about 96, 97% spindle load on this. and it was so loud you couldn't stand to be in the room without earmuffs and earplugs in. Now in this cut with iMachining, I'm actually at twice the depth that they were cutting at significantly greater performance rates, and the volume was low enough on it that as I was recording that video in front of the machine on my cell phone, you could hear me talking louder than the machine was creating noise. And the spindle load was at about 50%. So that was a pretty significant change and actually helped them with some of their OSHA requirements. Another area, when we start getting into like these massive aircraft bulkheads and exotic materials, this could be, 70-75 aluminum, or it could be titanium, right? Because of how iMachining works, because of how the algorithm maintains a constant load on the tool and it doesn't create a linear force against the part, in situations like this, especially with these thin walls and thin floors, we can machine this and absolutely minimize, or in some cases actually eliminate, some of the post-machining processes that have to go on, like thermal or vibration stress relief. Okay, we don't create the warpage that a lot of other systems create. Okay. So let's do a quick recap. Okay. With iMachining 2D and 3D, we're seeing increased performance. We're seeing reduced cycle times. We're seeing extended tool life, pretty significantly in a lot of cases too, by the way. We're seeing the best in the industry in cutting in exotic materials, and I'm serious. We've never seen anything like it. iMachining gives us the ability to cut these exotic materials at significantly higher performances than they've ever been cut before. And it's the best in the industry with the exotic tools. When you start looking at these ceramic tools, they're very, very powerful tools, but if they're not managed correctly, they break very easily. Okay, and so iMachining has the ability to control the motion with these tools and give you results that are staggering. And we can reduce noise problems. Some simple things that people very rarely think about when they're thinking about tool paths. Eliminate and minimize stress-induced warpage. I had one customer that was doing little tiny housings for electronics and such, and we were able to cut super thin floors and super thin walls, and he didn't have to do any kind of stress relief or reshaping afterwards. It didn't warp the part at all. It was one of the most amazing things he had seen. So to get this to the crux of where we're going today, SolidCAM's iMachining can help your company increase its productivity while at the same time increasing the life of your machines, your tools, and so forth. We can improve the quality of the parts that you're producing for your customers by giving you parts that are less stressed and have less potential for stress risers causing in-process fracturing and things of that nature. We don't produce those stresses that cause that. This can improve your profitability in several different ways. And so as we go forward, we welcome the opportunity to work with you, show you, demonstrate for you how iMachining can benefit you in your shop with the parts that you're working with. And you know what we always say, the best way to predict the future is to create it. Sometimes we need to change directions and do things different. It's kind of what we did with iMachining. We took a different direction at machining parts and tried to find better answers. So that kind of concludes the presentation today. Thank you, everybody. Have a great day, and appreciate your attendance today.